So look at this question. A ladder of fixed length h is to be placed along the wall such that it is free to move along the height of the wall. Okay, so which means the wall is fixed, the floor or the ground surface is fixed, which is free to move, the ladder is free to move, but the height of the ladder is fixed, which means they have given the height of the ladder to be h. Okay, the first question asks us to assume the distance between the wall and the foot of the ladder to be y and the height of the wall to be x. So we need to find the distance between the wall and the foot of the ladder y in terms of x and h. So we can use Pythagoras theorem for this. So h square is equal to, h becomes the hypotenuse, which is the ladder's height. So h square is equal to x square plus y square. We need to express for the first subdivision, we need to express y is equal to, or rather y square is equal to h square minus x square. Y is equal to square root of h minus x square, or h square minus x square. That is the required answer for first subdivision. There are two parts in the first question. Also, write an expression in terms of h and x for the area of the right triangle. So we know area is half into base into height. The base here refers to the distance y. The height here refers to the x part. So area is equal to half into x into y. But they've asked us to express in terms of h and x, which means we need to retain x as it is. We need to change y. So the area will be half times of x into, instead of y, we can write this as root of h square minus x square. This is the required answer. So there are two parts. One is y is equal to square root of h square minus x square, and the area is half times of x into root of h square minus x square. Find the derivative of the area. Now, area is a function of x. That's because h is constant. The height of the ladder is constant. The length of the ladder is constant. So, area as a function of x, I'm going to write this here. So, area as a function of x is equal to x by 2 into root of h square minus x square. There are two functions which are in product. So I'm going to use product rule to find the derivative of area function. So a dash of x is equal to, I'm going to keep this half outside, u v dash 1 by 2 root of h square minus x square. The derivative of the term inside, that will be minus 2x. So 2 and 2 get cancelled, plus vu dash root of h square minus x square into 1, because x is what? If you differentiate x, it becomes 1. So this is a dash of x. So we can take LCM, keep the half as it is. So divided by root of h square minus x square minus x square plus square root of, I mean, these two becomes squared. So h square minus x square. So this is h dash, I mean a dash of x. With respect to the height on the wall, which is x, and find its critical point. This is only one part of the question. We need to also find the critical point. So which means we need to equate a dash of x to equal to 0. So this will become minus, all this half will be gone. The root also will be gone. So minus x square plus h square minus x square is equal to 0, or rather 2x square is equal to h square. X is equal to h divided by root 2. So x is equal to h by root 2. That is, x cannot be negative. So I'm ruling out the case where we can use plus or minus. So it has to be only positive. So x is equal to h divided by root 2. That is the critical point. This is the critical point. and show that the area of the right triangle is maximum at the critical point, right? So we have got only one area here. We have got only one area. So, I mean, we've got only one critical point, which means there's only one maximum possible. Minimum is not possible at all, because if we take x is equal to negative value, the area will be negative. So that is not practically possible. So we can get only one maximum area possible. It is given that they've asked show that the area is maximum, which means we need to do a double dash of x. So if it has to be maximum, a double dash of x has to be negative at x is equal to h by root 2. So what I'm going to do is I'm going to keep this 1 by root 2 as it is. I'm sorry, 1 by 2 as it is. V u dash. So root of h square minus x square into u dash is, if you differentiate minus 2x square, it becomes minus 4x, because minus 2x square, if you differentiate that, it becomes minus 4x. If you differentiate h square, it becomes 0. So plus 0 minus v u dash minus u v dash. So u is h square minus 2x square divided by 2 into root of h square minus x square and into minus 2x. The whole divided by v square, which is h square minus x square. The root becomes squared, okay? So half into this becomes root of h square minus x square into minus 4x. Let this be like this itself. Minus, this becomes minus of minus plus 2x into h square minus 2x square. This is divided by the 2 and 2 we can cancel, maybe 2 and 2 will get cancelled, divided by root of h square minus x square, the whole divided by h square minus x square. So at x is equal to h by root 2, if x is equal to h by root 2, or if h square is equal to 2x square, a double dash of x is equal to 1 by 2 square root of 2x square minus x square into minus 4 into h by root 2. So this value entirely becomes negative, plus x into h square minus 2x square. So that part becomes h square minus 2x square becomes 0. The whole divided by root of h square minus. So this becomes, irrespective of whatever it is, this term entirely has become 0. So h square is what? 2x square. So this becomes x square. The whole divided by this will be h square minus x square. So h square is what? 2x square. 2x square minus x square. So as you can see, this is half into root of x square, which is x into, again, x we can write it as h divided by root 2, and then minus 4h divided by root 2, the whole divided by x square, or rather that can be written as x h square by 2. So what happens here is this half and this 4 gets cancelled. So you'll be left with minus h square by 2. So the value is negative. As long as the value is negative for a double dash of x, we can conclude that area a of x is maximum for that particular critical point, that is x is equal to h divided by root 2. So this is by using second derivative, we have proven that the area is maximum for the given critical point. Look at the third question, B subdivision. If the foot of the ladder whose length is 5 meters is being pulled towards the wall, so we'll try to draw this diagram. The ladder's length is 5 meters, and as given in the diagram, X is along the vertical side and this is Y. If the foot of the ladder whose length is 5 meter, okay, which means the ladder's length is 5 meter, does not mean the foot of the ladder is being 5 meter apart. No, it's about the ladder whose length is 5 meters. It is being pulled towards the wall, which means the foot of the ladder is being pulled towards the wall. As it is being pulled towards the wall, definitely what happens is the height of the top part of the ladder gets heightened. Okay. So what happens here is, so there will be an increase in the top or like the height of the top part of the ladder is increased. So look at this question. Such that the rate of decrease of distance y is 2 meter per second. So what I'm going to do here is I'm going to form a Pythagoras theorem equation. So we know that 5 is the hypotenuse, 5 square is equal to x square plus y square. So if I differentiate on both sides, not with respect to x, but with respect to time, because the rate of decrease is given 2 meters per second. So if you differentiate this, it becomes 0. That's because it's a constant. If you differentiate x square, it becomes 2x dx by dt plus 2y dy by dt. So the rate of decrease of distance y, which means they have given dy by dt. Since it is decrease, I'm going to use -2 for that. So this will be 2 into y, we don't know yet. So dy by dt is -2. This has to be 0. So 2 into x. Do we know x? This is the foot of the ladder is 3 meters away, which means the y value is 3 meters. If y is equal to 3, the length of the ladder is 5. So as per Pythagorean triplets, x has to be 4. So I'm going to substitute x as 4 here. dx by dt, we don't know yet. Y is 3 as per this question. So we can find out dx by dt from here. So dx by dt, see, as you can see, the y decreases. This was the initial y and this is the new y, which means y decreases. That is why I've taken dy by dt to be negative. That's because it decreases. Dx by dt is going to be like positive value, because x initially was only this much. It has now grown to this much, which means x has grown. So there will be a rate of not decrease, rate of increase for x. So dx by dt is going to be positive. So we can cancel this 2 and 2. So dx by dt, 4 dx by dt is equal to plus 6. Dx by dt is equal to 3 by 2. 6 by 4, which is 3 by 2. And the unit will be meter per second. So question asked is, what rate is the height on the wall? What rate is the height on the wall? Increasing. Okay, so you need to finish this question saying that the height on the wall is increasing at a rate of 3 by 2 meter per second. Okay.